October 18th, 2021. A call. Just kidding. Okay. The first one is just multiplication because they're side by side, right? So we get h of x equals 7 minus x over 2x plus 1. The domain is going to be x such that x is now in the reals, or negative infinity to positive infinity. And how do I know that? Because for addition and subtraction and multiplication, where both of them have domain is where the graph together will have domain, right? So they both are XER, so will this one be. It's also a quadratic, so that'll be the same. Range, what was the lowest value? Y such that y is greater than or equal to? Oh, less than or equal to? 28.125.
There's another one.
Yeah, and it's less than because this is a negative, right? So it's going to get you negative 2x squared. So from negative infinity to 28.125 square bracket. And then you could just type in your calculator and graph it, correct? So that one I'm just going to leave for you to graph. This one we'll graph together because it's more advanced. It's actually a rational. So h of x equals g of x, which is 2x plus 1 over 7 minus x, right? So it's a rational function, correct? So this gets me a vertical asymptote because nothing cancels. And it's going to be at 7 minus x equals 0. So 7 equals x. So at x equals 7, 1, 2, 3, 4, 5, 6, 7, I'll have a vertical asymptote. Then these have degree 1, correct? So my horizontal asymptote comes from the leading coefficient, 2 over negative 1. So my horizontal asymptote is going to be at y equals 2 over negative 1, or just negative 2.
Are the graphs going to be so dark?
Are the graphs going to be so dark?
Yeah, just because it's like really hard to like get your like dashed lines for your asymptote.
Well, most people, what they do is after they draw their asymptotes and they agree that they're correct, they usually go behind with a highlighter.
Okay. You're allowed to do that?
Yeah. So they draw it with pencil and then go behind and highlight the asymptotes and stuff like that. Now I know that it's going to have to be either quadrant. How can I draw the rest of this graph now? You would just use your, you could get points of values, or you could just use your calculator and plot points, correct? I'm not going to waste my time with that because you literally just go to the table of values and plot them, okay? Because I want to move on to the next lesson as well. So the hardest part should be putting the asymptotes on. And then you type it into your calculator, go to your table of values, plot points, sketch, right? Okay. This one, the table shows below the described. So I wanted to give you a table and a graph because sometimes you're given equations, right? And then you have to get the values off. Sometimes you're given a graph and you have to get the y values off. Sometimes you're given a table and you have to get the y values off. So I wanted to give you different examples of how you would do it because this is a unique situation. So here it says, if h of x is f of x divided by g of x, so it's this table divided by this graph, technically, right? Then the value of h5 is. So h5 would be, I'll write it over here, h5 would equal f of 5 minus g of, or divided by g of 5. F of 5 is 8. G of 5, I set you up for disaster. What's G of 5? It doesn't exist. Can I graph the graph of a function where they both don't exist? No, you don't have a y value to even use. So h of 5 does not exist on the graph of h of x. I picked a few of these so that they were a little, if I just do like h of 1 and h of 3, people are really good at that, right? It's when they're unique situations. So I gave you 2 unique ones and then one that's just a nice straightforward one. So if I go to h of 0, that would be f of 0. Oh, I did it again. H of 0 equals f of 0 divided by g of 0. F of 0 is 4. That's fine. G of 0 is 0. I set you up. So it's undefined, but it's actually a special undefined. What's it going to give you? It's going to give you no values there. It's going to give you a what? Vertical. I think people are saying it, but I can't hear you. Yes, a vertical asymptote. Sorry? It would be a written response. Or it might just be that they want you to graph the graph of these two. And what I want you to see by me doing these special little points, if you were to graph the graph of h of x divided is f of x over g of x, I want to do the special points because actually at x equals 0, you're going to have an asymptote. The graph won't exist at 5. You can only do the graph where they both exist, right? Yeah.
Wait, what? You're gonna have an asymptote?
You just can't divide by 0. So wherever you can't divide by 0, you're going to always have an asymptote. And when I talked about division on Friday, or Thursday, I don't remember when I talked about it, but whenever your second graph, the graph down here, has a y value of 0, you would go immediately, if you went to go sketch this graph, that would get me an asymptote, so would this one. So I would have 2, because that's where g is equal to 0. And g is the denominator. Now if they had flip-flopped them, g over f of x, then I would be sitting, I don't know, because I don't actually have it. So they would have to do it this way if they want you to sketch them, because there's not enough information on this one. Okay, then I gave you a plain one, h of 3. So h of 3 equals f of 3 over g of 3. F of 3 is 6, g of 3 is 1, so it's 6. Well, it's not really good if it's a blatantly obvious one, like 6. That's why I didn't give a whole bunch of those. I gave you one where you can't even find it, because there's not enough y values. I gave you one where you get an asymptote, and then I gave you one where it was nice math. Now this one I set you up. I'm going to see how many of you get it. So, I want the domain. So we have here m of x, and then I told you to switch this to h of x. I've already switched it on my document, on my computer, not this one. M of x equals x squared minus 4x minus 3 over square root 3x minus 1. Now, I told you that with addition, subtraction, and multiplication, and division technically, with a little bit of a check, you can only calculate the graph where they both exist, correct? You can't, we just saw that. You literally can't divide things if they both don't exist, right? If there's no part of that graph, you can't divide y values because there's no y value, correct? So I know that this one here, it's just division you have to watch out because your denominator also can't equal 0. So it still follows the same restrictions as normal, but also your denominator can't equal 0. So this one here would be XER, and this one here would be x has to be greater than or equal to a third. If you don't remember, you can always just, if it's linear underneath, you can just set it greater than or equal to 0. 3x is greater than or equal to 1. Divide by 3. X has to be greater than or equal to a third. Now, where they both exist is the restricted domain, which is x is greater than or equal to a third. We agree? And normally, that domain would be perfect. Normally, my domain would be x such that x is greater than or equal to a third, XER. Bless you. Now, if this was addition, subtraction, multiplication, that would be correct, because that's where they both exist, correct? Problem is, I also have to watch out for non-permissible values. We agree? So I state my domain technically where they both exist. That's my first step. So I'm not going to do this. I'm going to help myself out. Okay, this is part of my domain. And then I also say it can't exist where my non-permissible values are, right? Now, how do I find my non-permissible values? I just set my denominator not equal to 0, technically, right? So if I went square root of 3x minus 1, it can't equal 0. I square to get rid of the square root. 3x minus 1 can't equal 0. 3x can't equal 1. X can't equal a third. If it equaled a third, I'd get a 0 here, which is fine under the radical. But can I have a 0 in my denominator? No. So the answer is actually, you could write it like this, which is super, you'd have to watch yourself. You'd have to go x such that x, and normally you could go greater than or equal to a third, and x can't equal a third. But that's counterintuitive in this case. It would be x is just greater than a third. XER. So the thing to note is if, and I would leave myself a little note if it were me, and if I were writing out my review, which is your unit review, which I've looked at a whole bunch of them, and they're really nice. Majority of your reviews are really awesome. Some of yours aren't really awesome because they're not handed in. So that's a problem because I can't even see what they look like because they don't exist. Okay? But for the most part, what I've seen of people is they're very good. Okay? There's another one I handed out, radicals, rationals, and other functions, correct? If this were me, I would put this in the other functions and I would star it. Because this is one of those unique instances where I give you something that it's just a little weird, right? You would get your normal radical, but people forget to not put the equal sign because it's in the denominator, right? So whenever you have your radical, that's an excessively large pen. Whenever you have your radical in your denominator, you have to deal with the fact that it can't be negative, but you also have to deal with the fact that it can't be what? 0. So what you would take actually when it's in your denominator is you just say this has to be greater than 0. You would just wouldn't put an equal sign because it can't be equal to because it's in the denominator, right? So I wouldn't have went through all of this garbage. I would have just went to my denominator and said, hey, because it's a radical, it has to be greater than or equal to. Hey, because it's in the denominator, it can't be equal to. And then just solve that out. So that happens whenever you have a radical in your denominator. Do you see the difference? This is one people forget about all the time. People are really good usually with rationals, really bad once this happens, because it's just an easy, do you remember to do that or not? And then you get it right or wrong. Okay? We're going to flip to composition. This one. This is my favorite lesson of other functions. If you're really good at function notation, you're really good. Okay, something to note. If you see something like this, if I can drill this home, you guys will do much better on the test. That's a closed dot, correct? What does a closed dot mean? Multiply. That's nothing crazy. That's just what you've been taught, correct? So this is actually the same as g of f of x. Oh, but I'm getting ahead of myself. G times f of x. That's going to be the new one. G of x times f of x. Right? That's all that is. Closed dot. Do you agree? Or if I go like this, same thing. G of x times f of x. Today we're going to deal with not a closed dot, an open dot. Means totally different things. So you see closed dot, it's multiplications, and you see open dots can be composition. You have to spot the two. So many people will give me answers to multiplication when it's a composition, or composition when it's multiplication. They're not the same. Multiplication means you multiply. Composition, if I give you this, G open dot f of x, see, very different. Open dot, not open dot. That is not the rocket science part of this lesson. Okay? Open dot means composition. So when I see a closed dot, I immediately write it as G times f of x, correct? G of x times f of x. When I have an open dot, I go G, whatever comes first, I go G, and then I insert this in for its x, f of x. And then if I gave you, say, f of g of x, so f open dot g of x, that's composition. What does that mean? It means f, and then I'm going to put g in for its x. So f, and then g of x goes in for the x and f. So what if I gave you g, bless you, open dot g of x? It's an excessive. If I did this, I would take g, put it on the outside, and then I put g of x in for its x. Now to sell this home. We're going to sell this home. So if I give you f open dot g of x, say I give that to you, you would rewrite that as f, and then in for its x, where I would normally put an x, correct? I'm going to put the second thing, g of x. Do you agree? Okay. Now say I give you f of x equals 3, x, and g of x equals smiley face. If that's a true statement, I can take that g of x in the brackets, toss it out, and replace it with what? Smiley face. Now what the heck does this mean from grade 10? Take smiley face and put it in for the x is in f. So I get 3 smiley face. Done. You just use the grade 10 knowledge that if something is in a bracket, it goes in for the x's of the thing in front of it. That's it, right? If something is in a bracket, it's the x value of what's in front of it. That's it. If you literally know that, this is the easiest lesson of other functions. Okay? So, an example that doesn't deal with smiley faces is if I give you f of x is 2x plus 3 and g of x is 4x cubed plus 1, if I give you g of f of x, it would technically be the same as g, excessive bracket in there, of f of x. So what would I do? I would put in for f of x what f of x is. What is f of x? 2x squared plus 3. And what do you know when you're given something like this? If it's g of smiley face, I put smiley face in for x. If it's g of 2, I put 2 in for all my x's. If it's g of this, I put that in for all my x's in g. What is g? 4x cubed plus 1. So the 4 is going to stay the same. The x is going to become a bracket, and it's going to now become 2x squared plus 3. The cubed is going to stay plus 1. Do you see that all I did here was I took this, which is this, and put it in for the x of g, right? That's it. That's all it is. If this was g of 2, you would have went for 2 cubed plus 1, right? Instead of putting a 2, you're putting in a 2x squared plus 3. It's just bigger. But as long as you comprehend that if it's in the bracket, it goes in for the x, easiest lesson ever. No joke. Not making anything up here. Okay. Let's look at this one. Example 1. Now, when this would be the same as writing f open dot g of 1. But I would never write it like that. I wouldn't pick that as my option, right? So if it's in this form, that's awesome. Leave it in that form. If it's in the form with the open dot, rewrite it. Okay? When it has a number in for x, am I going to get an equation? What happens when we've had a number in for x? We always got a what? A y value, a number, right? This is just, hey, I'm putting an x in, and I'm going to get a y for what graph? This would actually be, when I solve this out, I'm going to get an answer for my y, let's say. This is on the graph of f of g of x, isn't it? This is on the graph of f of g of x. That's what I'm inputting the 1 into, isn't it? So when I put that 1 in, I'm getting 1 and something is a coordinate on the graph of f of g of x. I'm just getting a coordinate, right? Whenever I put an input in, I'm getting an output. That's a coordinate. Whenever I put something in for x, I get a y. It's a coordinate. That's all I ever get out of it. I don't get a whole graph. I get 1 point on it. So let's find out what it is. So we can do this part first. G of 1, we can do it off to the side. G of 1, going back to grade 10. This is why this part was so important in grade 10, but you didn't know it. G of 1, so we get negative 2 times 1 plus 7, which is 5. And you guys know function notation. What is this? What did I just find? A coordinate on what? The graph of g of x. If you guys understand this, no one can throw anything at you and get you stumped. If you can understand that that's what you're finding, that's the hardest part to understand. Okay, when I plug this in, it's an input for an output on the graph of g of x. That's all I did. So now for g of 1, it's going to always equal 5. Oh, wait, here's g of 1. I can put in what for it? 5. So this equals f of 5. Now I find f of 5. How do I find f of 5? Go back to grade 10. Fill 5 in for my x. 3 times 5 minus 5, which is 10. What did I just find? The coordinate 1 and 10 is on the graph. This is just an aside. This is not what it asked me for. This is the answer, right? To this question, the answer is 10. Circle it on a multiple choice, move on. Write in a numeric response, move on. To the answer, it is 10. But for us to understand, I just want to making sure we're understanding. Therefore, 110 is on the graph of what? We go back up here and just put an x in it, right? F of g of x. And what is composition of a function? It's just literally taking one function and plug it in for the x of the other function. Boom, get an answer. That's it. Yeah.
But if you're writing it like not like as a coordinate that this is equal to, then is it just f of g of 1 would equal
10. Yep. So this is the answer. F of g of 1 technically equals 10. That would be boom, boom, boom. That's the answer. That's it. I'm just making you understand, making you guys understand that we really just found one coordinate on that graph. That's all we did. The moment we plug an x in, we're finding one coordinate, nothing else. So I can plot a dot. That's it. That's all I have for that graph. Yay. Point. Okay? You guys try B. Pacha! So, we're going to do g of negative 4. And then negative 4. So we go negative 2 times negative 4 plus 7, which is 15. So we're going to fill 15 in. I just really want to say 15. Okay. And then we plug 15 into f. That. 3 of 15 minus 5, which is?
40.
Did someone say 16?
No.
Meatball Man said 16. The Strangler is what we call him, actually. Okay, so f of g of x, what is this? This is negative 4. This is the answer. If this was the question, that would be the answer. Please don't go further, right? If that is the question, the answer is 40. Circle it, move on. Okay? But I want to make you see if you understand. Negative 4 and 40 is on what graph?
F of g of x.
The graph of f of g of x, right, Lucas?
Yes.
Totally. On the graph of f, I am recording. Crap. Schmookus. F of g of x, the graph is negative 4 and 14. Okay. Now this one, we would have to just do the same thing. G of 1 is what? Off to the side. G of 1 equals 1 squared plus 3 times 1. I don't care if we take up the space because I'm going to just move on to the next example anyway. G of 1 equals 1 plus 3 plus 4, which is 8. So we now just found the one coordinate on g of x. It's 1 and 8. Great, lovely. It's our in-betweener. Then we put it in here, so we're going to get f of 8. Good answer. And then we're going to fill 8 into f of x. So we're going to get 8 minus 2 times 8, which is negative 8. Boom. Move on. So this is literally f of g of 1 equals negative 8, technically, correct? Which we just found a what? What did we just find? A coordinate on the graph of f of g of x, and it's at 1 and negative 8. Bless the knowledge. Let's move on. Next page. Roll and roll. It's a graph. Who cares? It's the same thing, right? Same thing. Now it's just a graph, or it could be a table, or it could be a different way of representing it. Doesn't matter. We're going to find f of negative 1 first. When you see a graph, you should not freak out. Life is easier. You don't have to solve anything. You just go find x, go to y, put answer, right? So f of negative 1, I go to negative 1, follow it up to f, and not the g graph, and I get 4. Okay, so I know f of negative 1 is 4. So now I do g of 4, which is, I didn't have enough space. It's 4. So now I found a point on g of f of x. It's at negative 1 and 4, right? So if I want to find all the coordinates on g of f of x, I'd have to plug in negative 4, find it. Negative 3, find it. Negative 2, find it. Negative 1, find it. 0, 1, 2, just like we did before with all the tables, right? Plug it in, get an answer. Plug it in, get an answer. Get a whole bunch of points, connect those babies, call it a day. Got your graph. No values in for x. What the heck is this? It's awesome is what it is. What it is instead of getting a point off the graph, we're actually going to get the function, the equation. Exactly. Be still my heart. You answered correctly on 2. I liked it. It was solid. So when we have a value for x, we plug it in, we get a point on the graph, correct? When we just have an x, we're literally just getting the graph, the whole equation, and nothing but the equation. So help me God. if you were not a juror, if you were sharing you were sitting down, what are those people called?
Jury.
Not a jury.
When you like testifying?
Testifying. Yes, this is why we need you here all the time on time. You've got so much knowledge. Testifying. You have to do this. Yeah. Thank you. Okay. So we have f of g of x. What are we going to do? We're going to say, hey, what is g of x? So we're going to write f of x squared plus 6. I just put g of x in there, right? I just went, hey, g of x is x squared plus 6. I'm going to put it in the same spot. See? 2 double lines, same thing. Do you see what I did? I just put g of x in for g of x. Now, what is our rule? Whatever's in the bracket has to go in for the x's in whatever the heck's in front. So this has to go into the x's for f of x. So f of x is 2x minus 9. So instead of the x, I'm going to put in x squared plus 6. So I'm going to go 2. That stays the same. X squared plus 6. Whenever I put in an input for a function, you have to put it in brackets. So whenever you do substitution, you always bracket it. And then minus 9 stays the same. And then you keep going. So you get 2x squared plus 12 minus 9. And we get 2x squared plus 3. Done. What did I get now? That is the function for f of g of x. That is the graph. It's a quadratic. So if I input g into f, I get a quadratic. It is 2x squared plus 3. It's lovely. Get a domain and range from that. Okay? Now, what if I do f of x? So what's my first step always? Substitute in that f in for that bracket. So f is 2x minus 9. And that's 2x minus 9 is going to go in for the x's in f. What's the only x in f? The x. There's 1. So the 2 is going to stay the same. The x is going to get replaced with 2x minus 9, and then I'm going to go minus 9. So you're literally inserting a function into itself. So we're going to get 2, and instead of the x, I'm going to put 2x minus 9, and then minus 9. So I get 4x minus 18 minus 9, which is 4x minus 27. Example 5, star, 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 so star, star, so star, 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 to star, star, to star, star. It's done the worst. We don't want that to be true, so we're going to start and study it. That's my singing song for you on my monotone. See, this is why I have to do vocalization versus not a vocal. I agree. It's like a rap. I could have been a rapper. Like rap math. No, I don't want to, make you jealous. So I'm gonna.
No, we won't get that.
You think, Grant, but he's like, I promise you. Okay, so let's look at A over here. So is y equals f of g of x. Now, paying close attention, what's the first thing we do? Nothing changed here. We're substituting a radical in. This is where life gets a little bit weird when we substitute radicals in. So when we substitute radicals in, what happens? My domain gets restricted because I can't have negatives under the radical. So the moment you are dealing with radicals, you're going to get a restricted domain. And usually, the questions that come about in composition throw a radical in there so that they can ask for domain and range, which makes it harder. Yeah? Okay. So we're going to go y equals f, and then g is going to be square root x plus 2, which is good. People usually get to here. And then at the end is where it goes really badly. So for the domain, not for the graph. You'll look at the graph, but you're going to draw the graph wrong. So we're going to insert this into f. So f has an x right there. That's the only thing that's going to change. So we're going to get square root x plus 2 squared minus 5. Can everyone type that into your calculator quickly? Type in square root x plus 2 squared minus 5. Yeah, into your y equals. What is it? It's a line, but does it keep going on for life? No, because why? I have a restricted domain because of my radical. But if I go to the next step, this is what people usually draw. So this isn't actually the equation yet, is it? The equation, I would go and I'd square root. What happens? It goes away. So now I have x plus 2 minus 5. And so my answer is x minus 3. And people will go and draw that, which you know better. You have the graph x minus 3 in front of your face, correct? But it only starts at what? Negative 2. So you can't just go and box this. This is actually wrong. This is the entire graph of x minus 3, isn't it? Do you have an entire graph of x minus 3 in front of your face? No. So I actually should not have boxed it yet. I should have put behind it x has to be greater than or equal to negative 2. Because the moment you had a radical, you still had a radical here. Do you see that? You still had this radical. So at this point, x plus 2 would have to be greater than or equal to 0. X would have to be greater than or equal to negative 2. At this point, that domain is restricted. It doesn't matter that it goes away here. When I type this in without this cancels off, you saw it only starts at negative 2. So if you just go and plug it in now, it's going to draw the whole line, which is wrong. So when you go to sketch the graph of this, you would have to go, that was relatively straight. Slightly impressed with myself. Pat on the back. Good job. Okay. So when we go to draw the line, it's at negative 3. And then I would go up 1 over 1, up 1 over 1, up 1 over 1. Don't be doing this in pen, Seamus. I mean, I can't. You're Seamus. I'm like Schmookus, but shame, you start with that. Schmamus. Okay. So if I draw the whole line, which is what people will pick on a multiple choice, or they will draw on a written response, they draw that whole thing. You're wrong. Where does the graph start at? Negative 2. So then I go behind and I go, nope, 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 nope. Gone. So it starts at negative 2 and goes on, right? So state the domain and the range. Often drawing it helps you with the range as well, or at least graphing it. So my domain in interval notation, or sorry, in set notation is x such that x has to be greater than or equal to negative 2, xcr. Or in interval notation, it's negative 2 to infinity. And my range is y such that y is greater than or equal to negative 5, yer. Or if I asked for it in interval notation, square bracket negative 5 to infinity. That is function notation. That's it. I'm sorry, not function notation. That is composition of functions. It's just inserting one function into the other function. It's literally it. So it's not a really hard thing, is it? It's not tricky to see it. But if you don't take into account this square root is sitting in there, you're going to get it wrong every time. Okay? So, pardon? Yeah. So anytime, or if you had a rational inserted. If you inserted a rational in there, you get non-permissible values, right? Which would also restrict your domain and range. So when it's radicals and rationals, that's why we did those ones first. So your homework.
Wait, so like, the rational end, would you get like horizontal asymptotes and verticals?
And possibly continuous spontaneity.
So any function still depending.
Yeah, you just look at the function at the end. The radical problem is it can cancel itself off. You might miss it. The rational will always stay. So you work your way to the end. Yeah. So your homework is 507, 2B, D, 3C, 4B, 5B, 6, 7. There's still some people who have not handed their homework in. And also not done the reviews. So there's a lot of catching up.